Here is a little mystery before we start. Imagine climbing exactly halfway up an A-frame ladder and locking the crossbar into place. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 16, and our lesson is all about Mid-Point Theorem. Before we start, a quick recap. In our last lesson, day 15, we studied properties of a parallelogram, opposite sides, angles, diagonals, intuitive proofs. If any of that feels unclear, pause here and re-watch day 15 first, because today builds directly on it. By the end of this lesson, student can visually identify the midpoint theorem pattern and apply it to break complex shapes into solvable halves. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. Imagine climbing exactly halfway up an A-frame ladder and locking the crossbar into place. That crossbar will be perfectly level with the floor, and it will be exactly half the width of the ladder's base. This happens every single time. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? The midpoint theorem simply states that if you find the exact middle of two sides of a triangle and build a bridge between them, two magical things happen. First, your bridge is perfectly parallel to the floor. Second, your bridge is exactly half the length of the floor. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today: statement, proof, converse, applications. In symbols, we write it as the segment EF is parallel to the base BC, and its length is exactly half of BC. Every word of that definition matters, so read it slowly. You already know parallelogram, congruence, parallel lines. This definition simply builds on those familiar ideas. Here is the key formula for midpoint theorem. The formula is, the segment EF is parallel to the base BC, and its length is exactly half of BC. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. In triangle ABC, E and F are midpoints of AB and AC. If BC equals 14 centimeters, find EF. By the midpoint theorem, EF equals 1 over 2 times BC. EF equals 1 over 2 times 14 equals 7 cm. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. Applying the rule when the connecting points are not exact midpoints. If you connect a point 1/3 of the way down to a point 1/2 of the way down, the line is neither parallel nor half the length. It requires perfect symmetry. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. If EF equals 5x and BC equals 30, find x. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. EF equals 1 over 2 BC, which means 5x equals 1 over 2, 30. 5x equals 15, which means x equals 3. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits midpoint theorem. We explored statement, proof, converse, applications. The one formula to remember is the segment EF is parallel to the base BC, and its length is exactly half of BC. Watch out for the common trap we discussed. And remember our goal: student can visually identify the midpoint theorem pattern and apply it to break complex shapes into solvable halves. Next lesson, chord properties, equal chords, perpendicular from center, distance. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.